So today we're going to practice drawing Bohr diagrams. And what I want you to do is I want you to look at the periodic table that's in the back of your textbook. And we're just going to remember some things about the periodic table that'll come in handy when we go to draw these diagrams. So if you find helium, which is in the top corner of the periodic table, you'll notice two very important numbers. The first number is the atomic number. If you remember from class before the break, the atomic number tells us the number of protons and the number of electrons that an atom has. The second important number that we have is the atomic mass. The atomic mass is the sum of the protons and the neutrons. Both of these numbers are going to be important for us in terms of the creation of Bohr diagrams. If you look at sodium on your periodic table, sodium has an atomic number of 11. This means that the number of protons and the number of electrons is equal to 11. We'll need this for our Bohr diagram. The other thing that we'll need is the mass number. The mass number of sodium is 23. Now, when you remember, 23 is the number of protons plus neutrons. To figure out the number of neutrons, we simply subtract the atomic number. And that tells us that sodium has 12 neutrons. Now we're going to use this to draw our Bohr diagrams. In the middle of a Bohr diagram, we always specify the number of protons and the number of neutrons. Sodium has 11 protons, which we write as 11p with a positive sign. It has 12 neutrons that we calculated, which we write as 12n with a 0 at the top to show that it's neutral. This is the nucleus of the atom. Because our atom has 11 protons, it will also have 11 electrons. The first shell in the Bohr diagram can only hold 2 electrons. We will place those together because electrons exist in pairs. The second shell of the Bohr diagram can hold up to 8 electrons. When we draw Bohr diagrams, we draw an electron on each side before doubling up. This shell happens to be full. So far we've placed 10 of the 11 electrons. We have to draw one more shell, and that's where our last. If we look at whether this element will lose or gain electrons, when atoms combine, we have to remember that they combine to achieve stability. That means they want a full outer shell. Because sodium only has one electron in its valence shell, or its outermost shell, it'll be easiest for sodium to lose that electron. And because there's only one electron in that outer shell, it will lose one electron. E with a line on top is a short form for electron. Because now it's lost one electron, it has one more proton than electron. So the number of protons never changes. It still has 11 positive charges, but now it only has 10 negative charges. So what ends up happening is the atom has an overall charge of positive 1 because it has one extra proton than electron. We write that as a 1 plus. The Bohr-Rutherford diagram of the ion is simply drawn to show that the atom has now lost that outer shell with just the one electron and has a full inner shell. So nothing in the nucleus actually changes. So we still have 11 protons and 12 neutrons. But now when we draw the element, we're only drawing 2 shells. Because remember, this atom gave up an electron. To show that it's an ion, we enclose it in a square bracket, and we put the charge of the ion on the outside. That's the Bohr diagram of the ion. So now let's try to do it with aluminum. So when we go and look at aluminum, aluminum has an atomic number of 13. So aluminum will have 13 protons and 13 electrons. Aluminum's atomic mass is 26.98, which we round to 27. 27 minus 13 gives us 14 neutrons. So we always do these quick calculations so that we know how many electrons, protons, and neutrons we have to place in our Bohr diagram. Going to the nucleus, I'm going to write 13 protons, so P with a positive charge, and 14 neutrons, so 14M with a 0 for no charge. There's the nucleus. Now I have to place my electrons. So that first shell, again, only ever holds 2 electrons, so we draw it in a pair. The second shell will hold a maximum of 8 electrons. So I'm going to draw my electrons around, again placing one on each side before doubling up. And I have 3 electrons left to place, so I will draw a third shell. Notice aluminum is in row 3 of the periodic table, and I had to draw 3 shells for electrons. Sodium is also in row 3 of the periodic table, and it also had 3 shells. So looking at aluminum, aluminum has 3 electrons in its outer shell. It needs to have 8 to be stable. It's easier for aluminum to lose 3 electrons than to try to gain 5 electrons. So the magic number here is the number 4. If the atom has fewer than 4 electrons, it will lose the electrons. If it has more than 4 electrons, it will gain electrons. At the number 4, it could do either. So going back to aluminum, we are going to lose 3 electrons from the outer shell. Lose 3 electrons. What that means is it's going to have a positive charge now of 3. Because if the element loses 3 electrons, that means it still has 13 protons, but only 10 electrons. So there are 3 extra positive charges. Now, when we go to draw the Bohr diagram of the ion, again, the nucleus stays the same. We still have 2 electrons in that first shell, and the second shell is full with 8 electrons. Remember, we don't draw a third shell anymore because the electron just gave up 3 electrons. And to show that it gave up the 3 electrons, we're going to use square brackets and write the charge of the ion on the outside. We have 11 protons. When we go to the next page, we'll be looking at drawing electrons, or drawing Bohr diagrams that do not lose electrons. These ones actually will gain electrons. So if you look at nitrogen, nitrogen has an atomic number of 7. This means nitrogen has 7 electrons and 7 protons. To determine the number of neutrons, we're going to look at nitrogen's atomic mass, which is 14.01, which we round to 14, and subtract the atomic number from it. That tells us nitrogen also has 7 neutrons. Now we're ready to start our Bohr diagram. So again, we're going to write the number of protons in the nucleus and the number of electrons in the nucleus. Because nitrogen has 7 electrons in total, we're going to place 2 in the first orbit. And we're going to place the remaining 5 in the second shell. So 1, 2, 3, 4, and 5. Notice that nitrogen is in row 2 and only has 2 orbits for electrons. When we think about whether the atom will lose or gain electrons, because there are 5 valence electrons, it's easier for the element to gain 3 electrons than to lose 5 electrons. Remember, elements always want to be stable. So this element will gain 3 electrons to reach the number 8. If it's gaining 3 electrons, the charge of the ion will be 3 negative, because if the element gains 3 electrons, it now has 3 more negative charges than positive charges. When we draw the Bohr-Rutherford diagram, we're going to keep the nucleus the same. The first shell is the same. The second shell has our original 5 electrons, but now notice this shell has gained an extra 3 electrons. I'm going to show those in red. Now you'll see that outer shell is full with 8 electrons. It has a complete octet. Because it's an ion, we're going to include square brackets around the diagram with the charge. And notice in this case, the charge of -3. We can do a diagram for sulfur next. So sulfur has an atomic number of 16, which means it will have 16 protons and 16 electrons. Its mass number happens to be 32.07, which just rounds down to 32, minus 16 gives us 16 neutrons. So now when we go to draw the Bohr-Rutherford diagram, we know we have to place 16 protons and 16 neutrons in the nucleus. And we're going to draw a circle around that nucleus because now we have to place 16 electrons. Notice that the second shell is going to be full. And we actually are going to have to draw one more shell. That last shell will have 6 electrons in it. So 1 on each side. And then we double up. Looking at sulfur, because it has 6 valence electrons, or 6 electrons in the outermost shell, it's easier for sulfur to gain 2 electrons than to lose 6 electrons. So it'll have an overall charge of -2. When we go to draw the Bohr diagram of the ion, the nucleus still stays the same. That first shell stays the same. The second shell still has 8 electrons. But now that third shell has the original 6 electrons. Plus 2 more, which I will draw in red. Because it's an ion, we draw the square brackets around and a charge of negative 2. Let me just fix that here. And that's how you draw Bohr diagrams and Bohr diagrams of ions.